We have a small recursive method that it does not retain any value, so the retained value is void, and it has a single input parameter as an integer. It's called num. The name of the method is short for recursive function, and inside it is implemented by branching by using only if and else statement. For the if statement is the base case or the stopping condition, and for else we are calling the method again. We have only two variables inside this method. We have the input parameter num and we have d, and d is equal to num modulus 10. So this expression gives us the rightmost digit of the input parameter num. So it has two variables and it has if and else statement. Notice that we are printing in three places inside the method. In the base case, I am printing using star, and in the else statement, before calling the method, we are printing using hash, and after returning back from the method, we are printing with $sign. So that whenever we see a star, it means that this print belongs to the base case. And whenever we see hash, it means that this print has happened before calling the method. And whenever we see $sign, it means that this print has happened after returning back from the method. So now we would like to trace our method by the input parameter 514. The idea behind the tracing recursive method is that you keep a track of the state of the variables of the method. And what does that mean? It means that before the method it calls itself, then you need to record or write down the current values of the variables of that method. For our example here, we have two variables. We have num and we have d. So before the method calls itself, we have to write down their values so that when we return back from the call, we have an idea what are their values. So if they are printed on the output screen, we don't lose a track of their values. So this is our output, and we are going to trace the method by the input 514. And in every step, if there is a print statement, then its result will be shown on the output screen. So this is the first call. So when we call the method the first time, 514 will be copied into num. So we write down inside a box the value of num, which is equal to 514. At the same time, we are starting in this line. In this line, we are computing the value of d, and it's equal to num modulus 10. And as we said before, this expression gives us the rightmost digit of num. And since num is equal to 514, so the value of d is equal to 4, and we write it down. Then we follow the logic of the program. Whenever there is a recursive call, then we have to repeat the same picture. So let us start. Now we check for num. Num is equal to 514, as indicated in this box. So it's not equal to 0. So therefore, we are going to the else statement. Now for the else statement, as you can see, we have a print. We are printing hash, the value of num, hash, and then tab. Now if we ask ourselves what is the value of num, simply go to the box and you will see that it is equal to 514. So first, what will be printed on the output screen is hash 514 with hash. And then we are going to call the method recursively. And here how it is indicated that we are calling the method, but what is the input parameter to this method? The input parameter is num divided by 10. Now num is equal to 514, and 514 is integer and 10 is integer, and you know that when you divide integer over integer, then the answer is integer. So therefore, when you divide a number over 10, in fact, you are deleting the rightmost digit. So the answer for num divided by 10 is 51. So we are going to call the method again, but this time we are going to call it with input 51. And notice that we have a statement when we return back from this call, which is the print statement because it is written after the call. So when we return back from this call, then there is one statement has been suspended, and that needs to be executed. So now we are calling the method again, but this time we are calling the method with input parameter 51. So what will happen? the system will make a copy of the method and it will jump to that copy. And again, notice that the print $4, why 4 is printed? Because the current value of D is 4. Notice that the print is suspended, so nothing is on the output screen. So now when we call the method the second time with the input parameter 51, we record the state of the variables of the method. So the value of num is 51, the value of D is 1. Why? Because we have 51 modulus 10 gives you the rightmost digit, which is equal to 1. And again, we test for num. Now num is equal to 51, so it's not equal to 0, so we are going to else. And inside else, notice we are first printing hash num hash with tab. Num is equal to 51, so this is why the output we have hash 51 and hash. And again here, after printing hash 51 hash, we are calling the method for the third time, because the first time it was called with 514, the second time was called 51, and now is the third time called with the input parameter num divided by 10. So num is equal to 51 divided by 10. As we mentioned, integer over integer is an integer, so the value of num divided by 10 is 5. So we are going to call the same method with input parameter 5. But again, notice after calling the method, there is a print $1, $1 because the value of D is 1. This print is also suspended. So it is paused for the moment. So when we return back from the call of the method, it is going to be executed. So let us see what happens when we call the method again with input 5. Again, we have to keep a track of the current values of the local variables. The input parameter is 5. And D is equal to 5 because num modulus 10 will give you 5. 5 is smaller than 10. And again, 5 is not equal to 0, so it will go to the else statement. And in the else statement, we are printing the value of num surrounded with hash. And this is the output. But when we go to the next statement, we have a call to the method. But what is the input of this method? It is num divided by 10. So what is the current value of num? It is 5. So 5 divided by 10, the answer, I know it is 0.5, but again, it is integer over integer. So the answer will be 0. So we are going to call the method with input parameter 0. But again, see there is a print after calling the method. But this is also suspended. So when we return back from the function with input parameter 0, it will be executed. So now when we call the method with input parameter 0, then the value of num is 0, and 0 modulus 10 is 0, so the value of D is 0. And since the input parameter num is equal to 0, so it will print 0 surrounded with the stars. And this is the output. And notice we are not going to the else statement, so we don't have to call the method again. So after calling the method with the input parameter 0, then we are returning back, but we are returning back to which place? We are returning back to the last call of the method. And this was the last call of the method. So we are returning back to this place because here we called the method with input 0. Now when we return back, there are some statements suspended. And in fact, we have only one statement, which is a print 5 surrounded by $. So it will print that one on the output screen. And again, we have reached the end of the method. And when we reach the end of the method, then we have to return back. But where we are going to return back? So we are returning here. And again, when we called the method with input parameter 5, a print statement was suspended. So this method has to continue until the end. So where it will continue, it will print 1 surrounded by $, and then it will return back to the previous call. And again, in the previous call, there was a print suspended. So this statement will be executed, and see the output, we have 4 surrounded by $, and then we are returning back to the first call of the method, and when we return back, we go to the main program, and this completes the tracing of the recursive method. So this is how to trace a recursive method. For every call of the method, you represent it by a box, and inside the box, you write the current values for every variable that you have defined inside the method, including the input parameter, just before calling the same method recursively. And then when you return back from the calling of this method, in other words, when you return back to this box, use the current values of the local variables inside the method to continue following or tracing the remaining statements that were suspended just before calling the method.